Morning, everybody. Yes. All right. So, formal welcome to all. We're going to talk about ACDC, the premier data validation portal for A-SPEC. So, my name is Philip Nell, and we also got Johan as one of our directors in the meeting today, plus a bunch of people interested in the subject. So, what we will cover today is around ACDC and A-SPEC. So, we'll talk a bit about standards. We will talk about the free tools that we have. We will talk about data creation a little bit deeper. We will discuss the portal solution. We will discuss the on-premise solution for ACDC and A-SPEC combined. We will have a chat about the rules editor we have. We'll touch on some of the rules and the checks that the portal has, and also the desktop, and that's what it's all about. After all, it's the rules and the checks and the eventual good quality data that comes out. We'll also talk a little bit about the graphic error markers, and that our solution is a mature solution and gives some proof of the growing usage of our portal, which we are very proud of. First thing we're talking about is standards. So ACDC supports multiple data standards, and you all might be aware of the ones that is out there. ADAC, F&Q ROC, there is more, but ACDC already have the tool sets and configurations for these. So obviously today we will focus in on A-SPEC itself, the one here in the middle, but there is websites where you can go and do a little bit of searching and get the ins and outs of the different standards. Of course, when you do talk about standards, you also have these thoughts coming around in your head and being discussed at length. So you can have your own standard because you could be of mind that your organization doesn't fit within any of those standards. One size doesn't always fit all. Maybe you want some customizations done, or you just have a really good one already internally and you don't want to change that and it's worked. We can accommodate all of those thoughts and processes at the ACDC portal because we allow for customizations and all sorts of different rules and data sets and schemas. So not just standard bound, but you can use anything. Now, we were talking about free tools. So in terms of the free tools, this slide will give us an overview of that. And then a little bit later on, we will look a little bit deeper into what's inside these free tools. But I can just clarify that the tools are free for the developers that is submitting to paying customers. So the developer itself doesn't have to fork out any money they are submitting to a paying customer of ACDC. So what are these free tools? Before I say that, these tools cover all of the sub-specifications of A-SPEC. So there on the right-hand side, W is water, sewer, drainage, roads, open space, and buildings. So all those substandards are covered. So what are these free tools? In the CAD world, it is a template drawing. Like you can see, there's an example, A-SPEC V3 Hotfix 1. So that's an AutoCAD or BricsCAD drawing. And inside that drawing, there is layers, all the pre-configured layers already in there, all the pre-configured blocks, and with all the attributes inside those blocks. So that comes for free to the data creation consultant. Then there's CAD menus. So inside CAD, to use those layers and to use those blocks, we've created these menus which will make it really easy for capturing and creating the spatial and attribute data. And there's a bit of more detail in slides coming. So if you don't know what a CAD menu looks like, we'll have a look at that. Moving then to GIS, you get a free set of shapefiles of every single feature in the A-SPEC group, and they're all empty. So you can easily just bring that into your GIS desktop package or whatever you use and fill that data in through maybe something else than CAD, like QGIS or whatever. So a whole set of A-SPEC files. Then the attributor. So the attributor is a tool that Spatial has that is also for free on the Autodesk App Store. And it allows for a better editing experience of attributes within CAD. The CAD one itself doesn't have a lot of features to simplify and make it a bit quicker to capture attributes. So the attributor helps you with that. It also comes pre-configured with domain values or attribute lookup tables as we call them. So the configuration is typically those two text files over there, and the app is also free on the App Store, which I will show a little screenshot later of. And the BricsCAD App Store. All right, so yeah, the BricsCAD template we have, as well as the attributor app on the BricsCAD App Store as well. And then, of course, the validation rules themselves. So I just made a screenshot there from the ACDC portal, which shows a few A-SPEC configured validation sets or rules. So when we talk about a validation set, that is the whole bunch of the rules, and we will touch on the rules a little bit later as well, that is pre-configured for A-SPEC. So there's the free tools that you can purchase for your developers if you are an asset owner. We're going to have a little deeper look into the data creation and how these tools look when you start using them. Right, so data creation directly in A-SPEC, what does that mean? It means a few things. So the A-SPEC layers, like I said, is already pre-configured. So this is just a screenshot showing a few D-SPEC, O-SPEC layers of new assets, and then which asset class or feature it is. So this is a screenshot out of CAD of the layer manager showing all the pre-configured layers ready to use inside AutoCAD. This one is the attributor menu. So we spoke about the attributor menu and the A-SPEC menu. So you'll only use the attributor menu when you configure this correctly. And you can see the A-SPEC features over there, pits and pits for swales. The item that's without the brackets and block, that is the feature itself. So you will pick that, draw the feature, then pick the block, drop the block, and fill in the attributes. And this you can see is already pre-configured there for water, sewer, roads, open space, drainage, and building. You also place the common block through the menu, and you can even jump to the portal if you want. So data creation inside CAD for A-SPEC becomes really easy. The next thing is the A-SPEC attribute capture. And this is a screenshot of what happens when you, in AutoCAD, want to edit that attribute block that is connected to the feature. And you see the interface of attributor. So you can see here, for example, all the lookup values for materials. You pick it. And this is just a quicker interface for that editing. Then we'll have a look at the GIS site a little bit. Oh, this is not even all of them, but this is the empty shapefiles you get as part of the toolkit. If you maybe not creating your data in CAD, but in a GIS environment, you can use these empty shapefiles, capture data, attributes, and features, and submit that up to the portal for validation. There's a screenshot of gravity pipes, the fields inside the shapefile. So you can see there's all the attribute names, column names with their data types and the correct lengths and precisions, all ready for use inside something like QGIS. So data creation, we're trying to make that as easy as possible for A-SPEC customers and developers so that the A-SPEC data can come into the portal with a very good chance of passing, with hopefully not too many files, but we'll get to that. The next is the portal functionality. So let's have a quick look at the portal functionality on a high level. So first off, we have the basic portal functionality, and this is this bit to the right here where you get CAD drawings and you submit that to the portal. You get the results, it does its thing, it sends no, it's failed, you have to fix it again until it passes, and that's it. So that's the real heart of the portal, and it does that job really well. And we're going to have a look later on all the errors and the tests and checks that the portal will look for, find, and tell you about. So it's important to know that that's the portal's core functionality, and it does that really well with A-SPEC data. Now, when we talk about the extended functionality, you will notice that there's a little bit more than just that core functions. Firstly, there's multiple formats. Now, as developers, you can obviously submit CAD drawings, but now you can also do map info and shapefiles. And map info files are fairly new. So the formats that the portal accepts is growing, and that is making the portal a lot more useful for a broader user base, and not just CAD on its own, but now also various GIS formats. The other thing that the portal does in its workflow is it supports project documents. Obviously, the as constructed data over here is the heart, and that's the important thing that the portal is doing. But You can also manage other project documents and their submission and workflow through the portal with ACDC and A-SPEC together. So what other documents? Inspection plans, maybe CCTV footage, any traffic management plan, a report, anything else can also be handled in the portal or accompany the drawing through the workflow. Now, the workflow itself that we talk about, so it's not just pass, that's it, and now download. There's quite a few things happening where the drawing fails and passes until that happens, and then it's certified, but not really accepted yet. So the customers have to review it, then it's accepted or rejected. And through that whole process, through this automated workflow, we also have notification emails going to users and groups. So everybody stays informed of what the status of your submission is, of your drawing submission as well as the project document. So there's this automated workflow and communications to who the responsible people are through the workflow. That's the extended functionality, and it adds a lot of value to the whole process of accepting project data. Also, another extension that is used is the download. So in the past, it was also just drawing files, but now you can also download shape and MIFs and in the format you want, so you can check the data on your side and then do with that what you need to do. So all of this is then portal functionality, and ACDC does allow customers and developers to just use a portal part of the solutions, and then there's no desktop at all. Everything happens in the portal, and these extended functionality or these extended tools assist with the whole workflow. So that's that I think about the portal and its core functionality and the extended functionality. So the next bit is we're going to talk about the bottom area here, and that's got to do with the desktop functionality. So the bottom one here, so this is where you want to integrate maybe with your third-party systems or other business systems down the line, GIS, asset management systems, and so on. But also, if you want to do validations straight up on your desktop with a desktop tool rather than going through the portal. And the other one is the desktop also allows for some configurations. So this is the same as the portal, but it's just doing the validation on the desktop. And I'm going to talk about the extended functionality on the on-premise solution that offers as well. So the first one is the conversion bit over here. This is the normal drawing file validation, right? So same as in the portal, it just happens on your desktop and you get the outputs from there straight on your desktop. The desktop tool also allows for drawing file conversion. So what happens in the portal is the file gets converted to shape drawing MIF, and you can download it and save it to your desktop and do whatever you want. So the same thing happens on the desktop. However, you can now convert this data to your local storage area. I'll get into that a little bit. The next one is you can edit the rules with the desktop tool. We call it the configurator. So you can actually add, remove rules, edit rules, change these things as you wish. And the validation rules are saved over here. And you are immediately ready to do a validation, maybe on a rule that you've changed to see if it passes or not. It also allows for configuration. What I mean there is how the data gets converted from the input or the validated past drawing, how that gets converted and where it gets converted. Right, so the next bit over here is talking about that. So this conversion can happen straight to just a drawing, obviously. Then you've got an AutoCAD drawing with object data, and you have that, or shapefiles. But what you have here is you can configure the data to go to a A-SPEC spatial database. This means that the data that comes in lands here in tables and columns and so on that represent the A-SPEC schema or layout of the features and the assets. So this can be really useful as a staging area. As the drawings go through here, maybe 10 a week or whatever, and this database gets all that data, keeps it in there, and the drawings can go off to a storage file somewhere or a folder somewhere. And then as your organization wants to use this data, maybe you have a follow-on post-process to then convert this data to whatever. The data can also be configured to go straight into your corporate GIS, and in Open Spatial's world, that means an Oracle database and the month's data schema, and it can just end up there, and it can then be displayed through our Enlighten product. But it could also be some other corporate GIS system, SDE, and Esri displaying that in their web tools. The conversion also can create a file that can be configured to be of the structure or of the layout that an asset management system requires. So all of these things are possible through the desktop and on-premise solution of ACDC. I mean, this is the core for the portal, this is the core for the desktop, but as we've seen, there's quite a bit of a functionality that adds value to how your data goes through the process and into your corporate systems. And all of that, remember, is then very well validated A-SPEC data to the agreed format and to the agreed rules. Doesn't matter who gives you the drawing or where it comes from. You've heard me talk about the ACDC desktop and the configurator. So the graphic configuration interface, this is the configurator. This is the bit that I was talking about over there. So we're just going to have a bit of a look there. What the ACDC configurator does as one of its big things, it takes the data that comes in from your drawing or from the template that we've made, and it links that up, those layers, those blocks, those attributes, those columns, the values, and it links that up to your end target space for that data. So the ACDC configurator, that is what it does. So let's have a look. So this is the configurator interface, and this is the, just on a high level, this part here on the left is the attribute blocks that comes out of the drawing that's open in AutoCAD at that moment. So it takes the template where we have all these blocks and layers, it reads that and gives you the chance to say, all right, so where do we want this to go? For example, this pipe, D-spec pipe, we want it to go to D-spec pipes in the ACDC staging database, and this is there. So when you press the convert button on the desktop, the data will go from the drawing and the blocks, blah, 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 through all of this, and it will end up in your ACDC staging database. In this case, it gives you an interface to link the source data that is now validated and perfect, links that up to your target spot, which in this case is an A-SPEC staging database. So the configurator, the desktop configurator, can do that. So this is for the features, all right? So this is to say this part, the feature itself or the object or the shape, that's how it works. The next one is how does the attribute work? So in the configurator, it's the same thing. In this case, when you use the configurator to take these attributes for pipes, for example, the length, it gets the length from somewhere, and here it says in the destination column name, in that table that we've mentioned before, is also called length, and it writes that value of that into A-SPEC. And this is a drop-down box that comes from the table. Again, so this is a graphic configuration interface, and it's very valuable for customers that uses A-SPEC to at least look at what's going on. Because this configuration is pre-configured for A-SPEC users, maybe the configuration itself is not so useful, but the fact that you can go in and look at exactly what is happening when you do press the convert button, you can at that point then see it in this interface. So to sum up, this one is for features, the objects itself and the tables, and this one is for the attributes. What we're going to do here is to start looking at the rules. So remember, the core, the heart of ACDC is to make sure that the A-SPEC or the standard that you're using, in this case, the A-SPEC, is being applied and the data that comes in does adhere to the standard. This is really important. This is the heart. This is what it's all about. So I've divided the rules up in sort of 3 groups: classic rules, extended rules, and then compound rules. The classic rules that we have here is simply mandatory or not. Is a field mandatory or not? If it's not, don't worry. If it is, check it. So simple. Then the data type. So characters, strings, integers, numbers. If it's the correct data type, check that. If it's not, tell us. Then the value must be in a range, maybe a minimum, maximum range for invert levels or for whatever. That is a classic rule. And then also that the value must exist in a predefined list. In this case, the pipe, the type, the value for that must be contained in or must exist in this lookup table pipe underscore type for D-spec. right? So this is classic rules. This is nothing earth-shattering. You would expect any validation system to at least have these things in so that your data passes some level of tests and checking. So the next one that we're going to talk about is a little bit of extended rules for geometries. This is linear branch and snapping. For linear branches, what we're saying is if you have service connections or property connections or service mains, as A-SPEC calls it, you want to know what is the actual pipe that they should be connecting to, right? This means it's a little bit of topology, making sure that the service connections actually connect to the correct pipes, and this is what you're getting in. And these are the layer names inside the drawing. So if they are drawn up correctly, then it will pass all these linear branch tests, and you can be assured there's nothing that doesn't. When we're talking about snapping of features to other features and what should happen when that snapping occurs, this is a bunch of snapping rules. So for example, if you run a water pressure main and you've got a valve, let's take the last one, the valve must be snapped to this pipe, to this main, and it must break it. So a valve cannot just be sitting on top of a pipe. It must break the pipe so that that pipe becomes then to length. So there's a whole bunch of snapping rules. Where do it snap? And if it snaps, what should it do? Break it or not? So that's sort of a next level.
Philip, we've had two questions.
Okay.
One is, how do we react to version changes, and can it support polygon data? I've given answers to you. I don't know if you want to address any of that during the process.
Yes, Johanna, you're right. The answer is that, of course, yes, it can. Points, lines, polygons, even the multi-part things, all of those. What was the second question?
It's about reversion changes in A-SPEC.
As part of the ACDC solution, we do have a subscription. So the first year you get the free tools as they are for that current version of A-SPEC. But we do maintain those tools and the validation sets as new A-SPEC versions comes along. And you can either subscribe to them, subscribe to ACDC changes for A-SPEC changes, which you will then just get the newer versions of the toolkit contents, or you can just purchase it again at a later stage. So yes, absolutely. We know about the one that's coming up in September or something, and we have had meetings with GISA and make sure that we are on top of what's happening there, and we start working on those things once the final versions are out. All right, so the next set of slides is all about the compound or the next level of validations. I haven't put all of them in here, but I've put in 9, and they can be used in a huge amount of ways. So don't just look at my examples or explanations as the only application for these rules. They can be applied. They are generic rules that can be applied to any attribute and to any object. So attribute checks. So I've got 3 here, single character check. You can make a rule to make sure that the last value of, say, a project number is a 3. And if it isn't, it won't pass, for example. So we are now talking about rules that is maybe not A-SPEC rules, but rules that can be configured in ACDC that goes a little bit beyond, but would make your life a lot easier when you review a drawing that has passed, but you can add additional rules to even further check the data and ask for improvements. So the single check character, so this is this one. Then you've got also substring, so you can also check for characters inside a string. So in this case, the GB, the project number, character 1 and 2 must be GB and must be uppercase, right? So again, this is just an application of the substring check, but you can also say, well, no, in the middle of it, there must be 3 characters and it must be 659 or whatever. So any rule that has this concept can be built with this compound validation rules that we now have. The multi-value check has been asked for 1 million years, and it's now possible. The example here is if the pipe material, if a pipe material is PVC, then the pipe diameter can only be a subset of what's in the lookup table or similar applications than that. It means it's not just about one attribute and what's allowed in there. If that value is dependent on something else, you can also configure that rule now. The next one here is spatial checks. And again, the rules here is really just examples. The first one inside So that's a classic spatial GIS one, to make sure that something is inside another one. So in this case, that all playground equipment is inside a park polygon. So maybe the playground equipment are points and the park is a polygon. And if someone drew a swing outside of the park somewhere, it will pick that up. All road center line must be inside the road surface area or similar. So inside check. Then the link limit and node limit checks. So this is all about how many objects are allowed to connect to either a link, which is a line, or a node. So how many pipes can connect to a manual? We're saying, oh, well, any number as long as it's more than one. You can probably put a max limit in there, but that should be okay. Node limit checks how many nodes can connect to a pipe. For a water pipe and valves, minimum 0, maximum 2 pipes to a valve. If someone tries to connect 3 pipes to a normal valve, that will be failing. Again, all of these is just examples. Now, the last set of slides of rules is about spatial and attribute checks together. For example, a related attribute check. So if this pipe is 50 mil, we must check that the fitting that connects to it is also a 50 mil fitting. So it might be a join, it might be a whatever it is. So it means you can configure rules on related objects. You can check the attribute of this fitting based on an attribute of this pipe. And, similar rules further on. This one is similar. It's an attribute link check. So in this one, you can say if you see these as two gravity pipes and the flow is in that direction, you can compare attributes across these two pipes. So you can say the end invert elevation of this pipe right over here must be either higher or the same value as the start invert elevation of the second pipe. And once you've configured this, it will just apply this across all drawings, all submissions, and make sure that that is true. And that's valuable downstream. If you start exporting GIS data to water models or sewer model softwares, you want these things to be correct. Also, if you start publishing data to 3D models like digital twins and all those sort of tools that's coming out now, you want the 3D visualization of this. If you start looking at this view is from top, but if you start looking at from the side, you want these things to connect up correctly. And this is a check that is available and can be used. Object distance check. So this is just an example of if you have features or objects that has to be further than a certain distance away from each other. And that might be a rule that the council have, or it's a general building rule or whatever. So in this case, there's this rule that says driveway polygon may not be within 7 meters of a roundabout polygon. So I've just zoomed to an area close to my house. There's this polygon. It's not my house, but there's the driveway. And this is just image. But if you imagine there's a polygon or a circle over there and a polygon over here, this test will make sure that these two objects are not closer than 7 meters. If it is, it will give you errors. Now, I guess I have to also say that these rules can be configured to be only warnings and not errors, meaning that you can sort of have a discretionary decision that decides, I just really want to know about these things, but I'm not going to have it fail the submission. So you can do that in ACDC as well. We just really want to know a few things and then maybe go look at them and inspect them, but not have the whole submission failed because of it. So warnings and errors is two different things in these compound rules. All right, so we're now going to talk about how the person that submits the drawings or the data, how they will know what's wrong. So we're not just going to tell them it's incorrect. We're going to tell them exactly what is not correct and where that error is. So on the portal, so this gray box here is on the portal. Once you've done validation and it maybe haven't passed, you can go to this action button, download the error markers. So this is if it's a shapefile submission and you need the errors in a shapefile, or you can download the drawing as a CAD drawing. Now you can see we've got a log file here, as well as the spatial features with their attributes in the DBF. So we'll quickly have a look at all three of these things. So the log file, the shape, and the drawing. So the log file will just be a text file like this. So I've cut all the errors at the top off to get the result summary, but all the errors sits there at the top, and the results will tell you how many objects, how many was analyzed, spatial attribute errors, and so on. So you can have a look at this if you want, but obviously the better way to do this is through Spatial tools. And this is a QGIS screenshot of these spec pit pipes and properties with the errors, which I made this yellow, so you can see the errors coming up where they sit. And then when you look at the attributes of these errors, you will also be able to see the errors themselves. So spatially, you can then zoom in and out and find all your errors, fix them one by one before you do a resubmission. The other way of doing this is obviously in AutoCAD. If your submission was a CAD submission, it will give you the errors as error circles like that. And if you click on them, you'll see the errors, and again, fix them one by one and resubmit. So error markers, graphic error markers, again, we try to make it as quick and easy as possible for people creating this data to create it and fix it and validate it. It's trying to streamline that whole time-consuming process at the start of the whole thing. And then later on, once it's passed, the data is high quality and it adheres to your standard A-SPEC. ACDC with A-SPEC is a mature solution. We've been doing this for over 10 years as a desktop solution and over 5 years as a portal solution. So it's a tried and tested thing. We've processed over 10,000 validations, 2,000 projects, and it is also growing. We can see the submissions over time, and that if you put a trend line there, you will obviously see that it is being used more and more, and we foresee that this will keep going as people realize that it is about the validation of the data, but it's also about the extended functionality and the integration to your workflow and to your corporate systems that is important. And it also allows for you to grow into the solution. Our pricing and structures and so on is such that you can start off with portal alone and then later on do desktop as well, or just do desktop for a start and then portal, do it internally for your own asset creation people, and then external for developers or whatever. All those scenarios are possible. We see this as a complete workflow solution, CAD, convert, and then asset management and GIS. So that whole workflow from design through to eventually the digital twin is covered, and ACDC covers up to there and then feeds data into the others. And then this is one of the very cool slides, is also showing the whole solution more in a picture way. So we're having a concept of what we want to do, then we design it and build it. Then there's the ASCONs, then we submit that to the portal, as constructed data being validated and passed. There's the validation happening through the portal. There's the workflow. Everybody gets notified. Everybody gets the information. Then the next step, the data ends up in your GIS and even in the digital twin. So that's the whole story. And just to iterate again, we did speak a lot about ACDC and A-SPEC, and A-SPEC is being used quite widely, and the tools are out of the box, already built for quick adoption and implementation anywhere. Right, everybody, thanks for attending. We really appreciate that. And if you need anything, please contact us. All right, so that's the As Constructed portal. So we do offer training. You can have a look at the training, and you can over here go to schedule a meeting and book yourself a date and time. So anyone want to do that, please do that. We will be in contact after that. All right, that's it. Thanks, everyone. Have a great day. Have a great rest of the morning and afternoon, and see you all soon.
Thank you.